All right, good morning, everyone. This is a question about homework 46, and this is problem 6B. Okay, so first off, I'm just looking at my picture and I'm trying to fill in my missing information. So what I can absolutely see right now is that this segment right here, right, that's a chord that's passing through the center of the circle. So I know that segment AB has to be a diameter. Okay, so that means that angle D right here, that's an inscribed angle. Vertex is on the circle. I can see that here, if I trace it out, these endpoints are the endpoints of a diameter. This is a semicircle, then has to be 180 degrees. So angle D has to be half of that, has to be a right angle. If I look at where angle E is, here's the vertex on the circle. So again, when I trace it out, it's an inscribed angle, vertex on the circle, with a semicircle as its intercepted arc. So it also has to be 90 degrees. So then if I focus on these small right triangles here and here, I know that for this one, these angles have to add to 180. So my missing angle right here, angle 1, has to be 40 degrees. And then over here in this triangle, I can connect the vertical angles here, make this 50 degrees, okay, which then again makes angle 3, well, it has to be 40 degrees as well. All right, so right now I know that the measure of angle 1 and the measure of 3, they're both 40 degrees. I could fill in another piece of information and say that, well, DE, right in here, right, if this inscribed angle is 40 and I double it, then DE, that minor arc, would have to be 80 degrees as well. Okay, from there, well, I do know that if this is 50, its linear pair has to be supplementary. So here's 130 and here's 130 degrees, those two slats. Okay, but I need to get to angle 2, right? That's my goal. So I need to figure out how are these arcs here and here, how are those related? So let me show you a few pictures just to help you see that relationship. Okay, so what I've done first, I want you to look at this visual for a second. What I've done first is I've focused on this right triangle right here. So triangle DAB. So let me bring that picture in, and that's what I'm focusing on, and I've reflected it vertically. Okay, so I'm looking at, again, this triangle right here. Okay, I have reflected it vertically into this position right here. So those are congruent triangles, right? All I've done is I've reflected the right triangle vertically into this position. Okay, we know that this side, the hypotenuse for both of them, is the diameter of the circle. Let me pull this part away for just a moment and slide this up. So then, if I take that triangle that I have here in red, and then I reflect it horizontally, so if I reflect it horizontally like that into this position right here, I can see that, oh, I have a rectangle. This figure is a rectangle. So I can see that. I'm going to add a little bit more to my diagram. So I know that if I connect these opposite vertices like so, each of those is a diameter of my circle, and I know that my diameter of a circle has to be the same as any other diameter for the same circle. So since I have a quadrilateral and I also have congruent diagonals, this has to be a rectangle. So that tells me that my opposite sides have to be congruent. So here and here, here and here, those opposite sides have to be congruent. And I know that these angles would have to be right as well. But what I'm really interested in is this relationship, which you're going to see in just a moment, because then I'm going to reflect this green triangle vertically into a position right here. Okay, so now here, I flipped it into this position. I just did another reflection. And now I'm interested in, again, this relationship here and here, where those two chords have to be congruent, which means that the two arcs here and here have to be congruent as well. So let me bring back my original picture right here. That was the relationship that I was trying to get to, is how are these two arcs related? And if they have to be the same, then I know that if this is 180, take away the 80 here, I have 100 degrees. These are the same. Take the 100, split it two ways, and I get a 50-degree arc here and a 50-degree arc here, which means that the measure of angle 2 will be half of 50, and this angle right here would be half of 50 as well. So I can see that this would have to be 25 degrees and 25 degrees. So the measure of angle 2 is 25 degrees. The two big right triangles here and here, again, I illustrated for you with a series of reflections how those end up being two congruent right triangles. All right, I hope that clarifies any questions on that problem.